Brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.
Thank you for coming. I'm Andy, and I'm going to talk to you about HTTP APIs and why they're different from all the other APIs you get to use in your language, and some of the pain that this causes, and how to get rid of that pain. So I'm a technologist, not an inventor. So it's kind of not really my remit to come up with new things. But what I tend to do is look at things that everyone else has done and try to apply them in new and interesting ways. So whilst what I'm going to present to you today is ostensibly new, I've actually just taken it from other people, and I'm going to show you how I took it from other people and why I took it from other people. And to do this, I'm going to show you a particular program I've written at my current company, Knodium, where we were binding the Dropbox API so that we could use files from our users in our web app. And leading up to that, I've got a couple of other little programs I've written that kind of inspired me in how to work this out, how to do it. And the first one is a program that writes other programs, and the second one is a program that writes programs that in turn writes programs. So a few years ago, my previous employer bought me a really nice laptop, and it had an inbuilt 3G modem on it. And I thought, what I've got to do is get a SIM card for this, so I can browse the web from coffee shops and get a load of work done. So I sent away for a SIM card, and it came with one of these USB dongles, and I was going to throw it away. And I thought, well, maybe I could do something interesting with this. Maybe I could turn it into a bit of an SMS gateway. Now it turns out that these 3G dongles, they use the same AT Command Set that your modem did back in the dial-up days. So I fished around on the internet and dug up essentially what is the API for these USB dongles, which is this AT Command Set. And this may look pretty terse, but this is the specification for the AT Command ATC reg, which tells the modem that you're going to register on the network and you want to start talking, like have a connection for your phone so it can ring and so you can make outgoing calls. And it's made up of 3 commands. One is the set command. You send it the state you want it to go into, so connected or disconnected, and then a read command to find out what it is. So this is the reply it gives you. It tells you what command it came back with, and it tells you which cell you're in, and it tells you the CI is a cell identification. It tells you like the local area code and stuff. And there's another API called with a little question mark on the end, which just tells you if this particular modem supports this particular command. And so I wrote I mashed up a little Perl program in a couple of evenings that generates C code that can read and write these things from the modem. And here's the test one. The other two are a few pages long, so I'll leave them elsewhere. So that was one API that I had exposure to that I had to get. I wanted to use in a program, but it wasn't just a module I could import. I had to write something around it to kind of write those commands into the modem. I had to work out how to put all the arguments in place, what the arguments were, whether they were strings or numbers, and all this kind of thing. And it can get pretty hairy pretty quickly, but all the information is actually in the spec, so if you can just take the spec and paste them in and then generate the code from that, then that seemed like a winner. The second thing I did was I was working in a database company. We were building this database engine, and we had a few bindings in PHP and Python, so people developing in those languages could use our database. And then we started to develop a plugin for the MySQL engine so that you could just put your normal MySQL tables in this database as well. And for example, one of the APIs that we had was the cursoring API for running up and down the results set, and you gave it some parameters and it gave you some return values. And well, what was happening was we were deploying this database, and customers were coming to us and saying, well, we've got this specific problem, and we'd like you to fix it. We've got a bug. We've got this weird behavior. And we try and reproduce this in our test environment. And we'd end up going back to them and saying, well, we can't reproduce it because we haven't got your exact data set, and they wouldn't be able to send us their exact data set because maybe it was a few hundred gigabytes, or maybe it was proprietary information, or maybe it was sensitive, or something like this. So what we thought was we need to send them something that can, instead of sending them a new build or changing the software, which can potentially change the bugs, let's send them something that they can load into the running database engine to find out what it's doing. Find out how they're calling these APIs from their Python programs, find out if they're doing anything which we hadn't expected. And our database ran on Linux, and there's this thing on Linux called LD library preload, which allows you to say, when the program's loading, just load this extra library in front of all the other libraries. And it allows you to take over the library function. So what we did was we wrote a program that took these APIs from our header file and generated exactly the same set of APIs. And what these would do was they'd make a log file and log what the call was and what the things were that in the parameters that the person was passing. And then it would call through to the original procedure to actually do the work. And then it would log what came back from that. And then it would return the original result to the caller. So what we had here was a program that wrote these particular programs which generated these log files of what the database was doing. And then we could get this log file from the customer, and we had another program which compiled that log file back into a program which exercised the original API. So we could actually take the customer's workload, trace it, recompile it back on our site, and run it against our test system. And so that was another exposure I had to kind of how to interact with APIs in strange circumstances. These days, I'm doing stuff that's a little bit more mainstream. I'm working at a company called Knodium, and we're an online website. We're a collaboration tool for students. So students go to university, they have things like Facebook and mobile apps in their real life. They go to university, and first thing they're told is, if you want to speak to your lecturer, you have to go to their office, or you have to email them. And what students want to do is they want to interact in a more familiar way to them than that. They want to be able to interact with their peers. Whilst when I went to uni, you'd kind of get around a coffee table and work through some problems. Maybe they want to share these problems with each other online and talk about them when they're at home. So that's the problem we're solving. And we've integrated with a whole bunch of APIs. So the students can come to our website, they can log in through their institution, and that means that they say which institution they're a member of. Maybe they're at Cambridge University. Our site sends the user off to Cambridge University's website where they sign in with their Cambridge University username and password, and then they get redirected back to our site where we can recognize that they're a student from Cambridge University. And we've integrated with a thing called MathJax so that engineers can put inside equations. So when they're having a discussion, they don't just use these words. They can put in their math equations that they're having a particular problem with. And we did something for chemistry students where they could draw in their organic chemistry modules, because what we were finding was that students were trying to do this on other social networks, and they were drawing them on bits of paper and photographing it with their phone and trying to upload it and having these very disjoint conversations. So we integrated with that. That's an external service called ChemDoodle that we use. And the final thing the thing that specifically I'm going to present today is Dropbox. So users can connect their Dropbox to Knodium. We can see what's inside their Dropbox, and they can say, import this particular file. And then they can say, well, this is the bit I'm having trouble with. They can create a snippet of it, and then they can drag it back into their conversation and have a conversation around it, just like they would with their equations and stuff. And I don't have a screenshot of the exact same snippet, I'm sorry. We wrote Knodium in Chicken Scheme, so the actual solution that I developed for integrating with Dropbox is going to be specifically in Chicken Scheme, but I've in the course of writing this presentation, I've kind of had to think about it, and I think you can do it in most of the popular languages today. I thought of a way of doing it in C, so you don't need a whole host of like functional programming or macro technologies to do an actual implementation of it, although the more of that stuff you have, the more elegant it can be. So in 2000, there was a guy called Roy Fielding who was writing his PhD dissertation, and he basically wrote this entire dissertation, and I'll summarize it for you there. He said, read the HTTP spec. It's got some good stuff in it. In fact, this is actually a quote from his dissertation. He just said that his dissertation is all about the lessons he learned when he was designing the protocol. And if you use the protocol in the way that I designed it, then it's going to be this really elegant thing. So there's this, I mean, preaching to the choir, right? You guys know what REST is, and you know how it works, and everyone's all over this. And this is a quote from one vendor's website presenting their REST API. This stuff is seriously complicated. They can't even get it right. I mean, I'm not going to name names, but they just put all this stuff about REST. They say, you know, wonderful architecture, wonderful principles, wonderful things, and then they make mistakes about the difference between a post and a put, and all these kind of things which don't really matter, right? Because at the end of the day, this vendor has a really good API, and the actual API documentation that describes the endpoints, it describes how they work, it describes how to do the things they want to do, is all really good. So despite all this complexity around REST, the APIs themselves are good, and the APIs themselves are actually the important bit. You don't want to get bogged down in all this kind of, is it REST, is it SOAP, is it XML, is it all these things. And when you say this to people, they get a bit upset about it. They say, well, you know, you need to know the difference between the delete and a post because a web crawler might come along and delete your entire website. It's all lies. But one thing that, one good thing that Roy Fielding did point out was that the media formats themselves are king. So the actual information embedded in the API call about your Dropbox files, about the directory structure they're in, how you specify that is really important, and that's the bit that you actually want to focus on when you're using the API. Now, in the break just a minute ago, I had a call, and it was from someone in the 90s, and they wanted their distributed computing environment back. The distributed computing environment was a software system developed in the early 90s, and they had a thing called DC RPC for remote procedure call. And the Wikipedia page says, DC RPC system allows programmers to write distributed software as if it were all working on the same computer. Very good. The important part, which I'd like you to keep in mind, is that they wanted to do it without worrying about the underlying network code. And this is something that they managed to achieve then, and it's something we've lost now. And maybe we can get that back. So, as if everything I've already told you is common orthodoxy, I'm going to be a little bit heretical and say that actually, whether or not you're doing a REST call or a SOAP call or an XML RPC call or any other SOA kind of calls with TLAs and ETLAs, it's all just an RPC, right? At some point, when you make your API call, somewhere on a server in a farm somewhere, a procedure call happens. And whichever kind of brand of Rastafarianism you practice, that's what you wanted to happen, right? When you made your API call, you wanted something to happen and to get a result back. So there was a guy on Stack Overflow, he said, I'm looking for a pretty generic, fully featured REST client in Python, not bare bones, plush, and nice to use. And this was my first signal that I was kind of pushing against something that is not talked about, because his question was closed as not constructive. Sorry, you are not constructive. You will not talk about these things. But he went away anyway and came back and edited the post and presented a couple of things he'd found. One of them was this one that said, and again, I'm not going to name names. It's an API resource kit for Python. It allows you to easily access HTTP resources and build objects around it, right? That's exactly what we want, right? And then it goes on to say, it's full HTTP client using socket calls and its own HTTP parser, and these are things that we don't want. And then it goes on to list a whole bunch of features all about the network protocols and other things that aren't really interesting for your API. He found, I did some other research, and every time you come across a tutorial on how to use an API from on the web, it says, right, first get your HTTP client out, and then make a URL, and then paste these strings in, and then send it off to a connection pool, and then get some things back. And the best one I found was actually this one. So this was one of the other ones that he posted on the Stack Overflow post. He starts off pretty well. It says, I want this object in my language, and I want it to be bound to this HTTP API. That's about as simple as it gets, right? And then things go a little bit south. Suddenly, in this interface that you've got in your language, you've got all this detail about whether it's a GET request or whether it's a POST request, and this kind of API. Maybe you want your API to be a bit more rich than just, is it a resource and does it have an array index? Maybe you want to talk about a list of files if it's the Dropbox API, or a list of messages if it's a messaging API, or maybe even a folder of messages or something like that. And you certainly don't want to worry about whether it's a GET or a POST at this point. So that's my quick survey of the state of the art. The other way that people bind to APIs is to use the vendor's SDK. And this is pretty popular, especially if there's one in your language. And so I had a look at some of those as well. And almost every one I saw, in fact, I think every single one that I found had an HTTP client written inside there. Some of them called them REST clients, which are just badly written HTTP clients with BSMIS out. They dealt with socket pools, and they dealt with things that build the request, and they dealt with things that pasted URIs together, sometimes in insecure ways. And some of them even had entire oauth implementations inside there. And none of those things are the API. None of those things are things you care about. And then they did it for every language that they support. So there's a big matrix of bugs and security vulnerabilities and opportunities for you to make a mistake. Every vendor's doing this on his own. And a lot of languages, like I've picked on Python a lot, that has some fairly good URI libraries inside there already. It has some fairly good HTTP libraries inside there already, and they're not using them. Now I'm going to go back to my C roots again. So I'm going to do a Python example again. There's a Python module called ctypes. If you want to use a C API or a C library, you can use ctypes, and you say, import the library. In this case, I'm going to do a silly example with the Unix, the POSIX C library. And then you say, I'm interested in the printf function, which I guess everyone is familiar with for putting words on the screen. And I want to call it my printf. And then you're done. That's it. You're finished. You can just start getting on with it. You can call it from Python. It prints the thing out. It returns the number of characters it printed out. And you can, you have all the arguments there for passing in variables and stuff. You show this to people and they say, yeah, it's not complex like the web, is it? And it is, but it's hiding it all for you, right? It's doing code loading. So it's loading that library, it's getting that library from disk and putting it in memory for you. It's dealing with the fact that it's in C rather than Python. So Python is a virtual machine language. When you call procedures in Python, it's different from calling them in C. When you call them in C, it's got to put all the arguments on the stack, and it's got to set up all the boundaries and pop the stack frame and all sorts of crazy stuff. Python doesn't do it in that way. It's got to do marshalling, so simple things like numbers and strings and characters are different in Python to what they are in C. So in C, they're null terminated, and they're sometimes they're UTF-8, sometimes they're just 7-bit, sometimes they're random 8-bit code pages. In Python 2, there's one set of string representation. In Python 3, there's another set of string representation. So ctypes deals with all that for you. And on the web, that's something like, do I get JSON back from my API, or do I get XML back from my API? And then it deals with memory models. So Python is a garbage collected language. When you pass something across that interface, the C code expects that thing to stay there. If the garbage collector comes along and moves it, the C code isn't going to expect that. And so ctypes deals with that for you and makes sure that while the C code's running, all the things stay in the same place in memory. So in order to do this for web APIs, what you need from your language is these 4 things. And I'd argue that most languages that most people at this conference are writing in have these things. They have an HTTP implementation which understands about how to structure a HTTP request, how to read a response from an HTTP server. They have an HTTP client which can actually send a specific request to a specific server and get a specific response. They have libraries for building up URLs and decomposing them and adding query strings onto them and this kind of thing. And they have media format libraries, so they know how to read JSON and turn it into a Python data structure. They know how to read XML and turn it into a dict or something like this. And all you need to add to this is a way to put it all together. And that's what I'm going to do. So first you need to deal with the calling conventions, right? In a API such as this one from Dropbox, the calling convention is you put the path on the end of you put the path of the Dropbox file you want on the end of the path for this HTTP endpoint. And now how that's encoded is something that I had to deal with, because if that path got a slash in it, do you put more entries into the HTTP path, or do you encode those slashes as just one entry? And that's a bit ambiguous in the Dropbox spec, but it works. Both work. And maybe you've got some kind of sample API that tells you the price of a currency conversion at a specific date for a pair of currencies. And all these things are called positional arguments, right? If you put them in a certain position, they mean certain things. So if you swap round the date and the euros, then the API call doesn't work anymore. And the other way that HTTP APIs typically do things, so this is what it might look in if you had a Python procedure that did those API calls from some kind of other library. The other thing that they have is keyword arguments. So these ones, they don't matter what order you put them in, but it matters you put a certain key equals a certain value. And Python has those too, right? You can make procedure calls like this. And you can combine them. So you can have some positional arguments, and then you can have some keyword arguments. And they would look like that. Like I said, in Knodium, we're writing in schemes, so I'll just quickly show you how to define a procedure in scheme. You say define, then you say the name of your procedure, and you say the positional arguments, and then you say a special token, and then you name the keyword arguments. And then you write your procedure. So if you were doing add, that adds two numbers, you define it like that and implement it like that, and then you would call it. It's similar to the Python call, it's just we put the parentheses in a different place. We put them before the procedure name, not after, and then you get your result. And I can never remember which way around the arguments go with the exponent procedure. So I might want to say an API like that, so I can raise 2 to the power 4 and get a result like that. So what did I do? I kind of took inspiration from all these things I'd done, and I thought I need a way to bind REST APIs. So not very imaginative, I called it REST bind, and it gives you this thing called define method, and you say what you want to call it. You tell it about the positional arguments, you tell it about the keyword arguments, and then you tell it a bit about the API. So you give it a URI or request. I'll come back to what that is later. You give it a body writer. So some requests, like GET requests, don't have a body. Some requests, like POST requests, they have some information that goes along in the body of the request, like the file you're uploading or something like that. There's a body reader which knows how to read the response that comes back from the server. And then optionally, this is something I added later, some APIs say set certain HTTP headers in the response that you need to know about, so you can have an opportunity to read those guys as well. And the Dropbox account info API is the very simplest one. It doesn't take any arguments. It just tells you what the account information is for the current account. And so you say define method, account information. Actually, it does take a procedure. You can get the information back in different languages. So there's a locale thing. It's at that endpoint. We don't need to give it any information, and the response comes back in JSON. And once you've called define method, there's now a procedure available called account info. So this is the next bit, the marshalling and the unmarshalling of the data structures. I was going to suggest that no one cares about JSON, right? It's not a first-class data in any language, but it is. There's some languages where it's a first-class data structure. But in Python, you've got Python dicts. In Java, you've got plain old Java objects. In other languages, you've got other things which aren't JSON. And JSON's not necessarily a very good way to interact with the API. All that you want the JSON for is just on that transport between your client and the server. You don't want it anywhere else. So if you go and look this URL up in your web browser, you'll get this big string of JSON back. What we want to do get back is actually our dictionary structure, so we can look up specific key value pairs to find out the name or something like this. So if you define that with define method with the string reader, you just get a string back. But if you put read JSON in the declaration of the interface, you get a data structure in your language back that you can then go and do things with. You can pass it around, just as if this was some other API that you'd imported or downloaded from the Python eggs or something like that. This one is an example of a trade API. So you give it a stock and you tell it, I want stock quotes every 3 seconds. You bind it very simply. But maybe the guy who implemented it didn't understand REST very well or something like this. Maybe he said, you've got to do this with a put request. So let's go back to this URI request thing. In the common case, in the common simple cases, the URI request is automatically built into the thing which goes to the HTTP client. And if you specify a body writer, we do a post request. And if you don't specify a body writer, we do a get request. But in this case, the guy said, you must do a put request. So we just changed this and put a request object there instead. So the HTTP implementation in the scheme knows about request objects. You just say, it's this method with this URI. And then you check the documentation again. He says, oh, and you must set the accept header. So you set the accept header as well. And then you have your procedure available, you call it, and you get all the tick data. So that's the main thing that I want to do. It's kind of just, like I said, just taking these 4 things which are available in most languages, putting them together in an elegant way that allows you to not worry in your SDK about how to build a URL, how to have a socket pool of connections to the web server and this kind of thing. And if you want to just use one API from someone's website that hasn't provided an SDK for you, or you don't want to install their SDK, you can just quickly get a procedure in a few lines in your language. And it turned out that it was 66 lines of code. I did use a little bit of fancy smancy stuff like macros and procedures, but not very much. I reckon you can do it in that order of magnitude in almost any language. So I made a module called a low-level binding. We have this pattern in Schema when we bind to APIs, we do a low-level one which just exports the procedure calls as they are in the original library, and then we make it more schemy or make it more Pythonic by building a higher-level binding around it. And this file was I just copy and pasted from the API Dropbox implementation. I paste in 20 lines of comments about how the API worked and then do 6 lines of defined method for each one of them. And then I built a much higher level SDK around it that actually cares about the domain-specific parts of Dropbox, like the account metadata and the file metadata and how to store it in a database so that we can have an ls procedure which does a directory listing and this kind of thing and returns directory items which have the MIME type and the icon in, and all these things that aren't in the official Dropbox SDK because they spent all their time building OAuth implementations. So the other part, of course, you're all wondering is how does he get the authentication of these APIs? A lot of these APIs require keys or require request signing and that kind of thing. So OAuth is quite an interesting one. I guess you all know it, so I'm just going to do a very quick overview. But let's say there's a service that has files, and the user has his files on that service, and she wants to go onto Knodium, and she wants to tell Dropbox to send her files to Knodium. So she tells Knodium to ask Dropbox to ask her to whether Dropbox is allowed to send the files to Knodium, and then if she says yes, sends the files to Knodium, and this procedure happens once, and then we know like Knodium, we know some secrets, so that later when they come along, they can ask us, they can say, I want you to fetch this file from my Dropbox, and then the Dropbox will send it back to us. So if you're an SDK implementer, you take the OAuth client library and you define a service provider, which is just the endpoints of how to do the authorization, which version of the protocol you're using, and how the requests are signed. And then, as the user of the API, so the guy implementing the website or whatever that uses the Dropbox, you just combine the service with the secrets that you know from that authentication procedure. So we've got the secrets, everything's set up. The API again is very simple. You just say with OAuth, this application and these credentials, you've got the API you want to call, and you put one inside the other. And so this is using a thing we have called dynamic scope. Now, the way we implement it is with parameters, and essentially it sounds all very complicated and functional programming, but actually all it is global variables, thread local global variables. So if you've got multiple threads, each thread has its own copy of the global variable. So at the start of the with oauth call, you say, you put the credentials in some global variable somewhere, and at the end of the oauth call, you put them back to how they were at the start. And then at any point in the scope of, in the runtime of that code, if you call an HTTP API, it'll intercept it and just sign the request and then send it on its way. So you can take your account info API and you can write your low-level binding for it, and you can wrap it in a kind of a higher-level binding, which maybe finds out the name of the person who owns the Dropbox, and you can wrap it in a web page, and you can put it into your web framework. And then at some point, quite far removed in a completely different part of the program, you can just wrap the whole thing in with oauth, and it will sign all the API requests will become signed with that secret, and so they'll work for that particular user that you have the secret for. So we don't actually mix in the authentication part of the API with the API binding itself. They're entirely separate things. And that's all I've got for you, I'm afraid.
Brought to you by MuleSoft, provider of the industry-leading Anypoint platform for APIs.